Okay, we're now going to look at misconceptions with powers and roots. So first of all, let's look at the facts. So we know that x to the power of minus n means 1 over x to the n. So something like x to the minus 3 is 1 over x cubed. Now, again, I'll give you the misconception first this time. Big misconception people have, or I see lots and lots and lots, there's something like this. 2x to the minus 3 is equal to 1 over 2x3. Well, that's not true. In this case, it should be 2x minus 3. Well, look here, it's kind of big mass. This bit separate. I do the power before I times. So I'm going to deal with that power first. So x to the minus 3 is 1 over x cubed. Then I'm going to times that by 2. So that's going to give me 2 over x cubed. Yeah, so the rule is x to the minus n is over x to the n. Yeah, the number stays in the top. Yeah, and conversely, I've seen this is a mistake. That's something like 1 over 2x cubed, so the one I just put on there is the same as 2x to the minus 3. But again, that's not the case. In this case, 1 over 2x cubed, well, I can think of that as 1 over 2 times 1 over x cubed. So that just becomes 1 over 2, and 1 over x cubed is x to the minus 3. So again, the number stays as a number. It's only the bit that's attached to the power that changes, look. So the x is attached to 3, so it's the x that gets the minus 3. The half, the number, didn't change. Okay, and you also know, hopefully, that something like x to the 1 over n means the nth root of x. So something like 125 to the power 1 over 3 is the cube root of 125, so it's just 5. And the misconception I see for this one is something like this, 4x to the half. I see people write that as 2 root x. And they do that because it's square root 2 and square root x. That's not true. Again, the half is just with the x. So it's really 4 times x to the half. So that turns into 4 times root x. Okay, let's do a few more powers before we do some roots. So the next power one, we know that the rule is this: a to any power times b to that same power. Well, I can times the numbers together first and then put that to a power. So something like this: 2, let's do 2 cubed times 5 cubed. That's the same as 10 cubed. Yeah, if you don't believe me, check that out on your calculator. Yeah, but a big mistake that I see is I see this. I see some people doing 2 times 5 cubed is 10 cubed, where that's not true. Again, check that on your calculator. So I can't just do this. I can't do a number times a number to the power n, like that, and times the numbers together first, then do the power. Yeah, that doesn't work. Yeah, if they're both at the same power, I can times by the numbers first. That's the same with dividing. So if I change these to divide, actually, let's write that out again. So if I change it to divide, a to power n divided by b to power n, I can divide the numbers first. Yeah, and the mistake I see with that is, again, I see stuff like this: a to the power 10 divided by 2 is 4 to the power 10. I can't do that. If there was a power 10 there, then I could do that. That would be right then. But if there's no power 10 there, I'm not allowed to divide by 2. I'd have to work this out number first and then divide by 2. Okay, the next one comes with brackets. So something like, let's give you the number example first. So if I had something like this, 6 plus 2x cubed. Yeah, so you can see that bracket and you'd be tempted to kind of factorize out the 2, because look, they've got a common factor. Now, if I just wrote this, it's not true. Because you think about what cubed means, it means I've got 3 of these brackets. So I have 3 lots of 2s, so I need a cube there. So if I factorize out a number, the power goes with that number as well. And conversely, I can't do this. I can't do 2 times a bracket and then just expand by the 2 like that. That doesn't work. Yeah, it would work if there was a 3 there. Then I could take the 2 inside because they've got the same power, so I can times numbers together. But if they don't have the same power, then I can't do anything. Okay, and last one of the powers is the famous one, something like this. A plus b to the power n doesn't equal an plus bn. That's a big mistake at C. So something like 2 plus 3 squared doesn't equal 2 squared, not 3 squared. Yeah, to get the right answer, we would have to expand the brackets. Well, it's easy if it's numbers, so let's change that to letters. Let's do 2 plus x squared. I'd have to do 2 plus x times 2 plus x. Yeah, and that's true for whatever the power is. I would have to expand it all out. And again, all this works with roots as well. So I'm just going to go through that quickly. So stuff like this, root a times root b is root a times b. Root a divided by root b is root a over b. Yeah, we know that. I could put some numbers in there and we can have a play around if you want. But the main one I want to look at is let's find it. This one here. So same thing as before. If I've got root 4x plus 8, what I'm not allowed to do is I can't take out 4 and then just write root x plus 2. Yeah, if I want to factorize out the 4, I need to factorize out the square root as well. So it does equal to root x plus 2. That works. And similarly, if I have a number in front of a square root, so let's do x plus, let's do 1. If I want to take that 3 inside, I'll need to write that as a square root. So I need to write that as root 9 times root x plus 1. Now I can expand it to root 9x plus 9. I can't take the 3 inside and do 3x plus 3. That doesn't work. Okay, and the last one, the roots. If we have something like, let's give you the error first, root x plus y doesn't equal root x plus root y. I can't split the square root. And a perfect example of that is if I stick some numbers you'll be used to, root 9 at 16 definitely doesn't equal root 9 at root 16. Work out these numbers for yourself to double check. If I want square root something like this, you just can't have to work out this bit first, then square root. So now, these mistakes normally come from equations. So something like this, if I had root z equals x plus y. A common misconception, common mistake I would see would be, people would say, right, I'm going to square this, and square this. So z equals x squared plus y squared. But that is definitely wrong. You're not allowed to do that. What we should do instead is instead of squaring each thing individually, I'm allowed to square each side. So in this case, I would get root z squared is z. This squared, I would expand and get x squared out of y squared at 2xy. I'm allowed to do that, mathematically that's right. This, I'm definitely allowed to square individual terms, only square sides. And the same with square rooting. So if I had something like x squared plus y squared equals 100, you might be tempted to kind of square root each thing and write down x plus y equals 10. But again, that's a big no, makes no more sense. What you could do mathematically, if you wanted to, I could square root this whole side and square root this side. So I get root x squared plus y squared equals 10. But then I can't really go anywhere from that. So it doesn't really help. It's probably better to leave it as x squared plus y squared equals 100.